Okay. So we did, so we're on page 21.
Can we go over B really fast?
Sure. So we finished up with B the last class. Remember, if you're trying to approximate cube root, fourth root, square root, or it could be anything. It could be 1 over x or 1 over something. You want to just first make that your function. So f of x is equal to cube root of x. Okay. And then establish a value of a that we could easily evaluate. So that we can figure out the derivative. We could figure out f of a, which is 3. And then we can plug that in to find, remember, this is really, this is the tangent line. We're using, so if you take all of this information, what's the tangent line? Y minus y1 equals m times x minus x1. So what are like the f of a, right? F of a is our y1. So here's a. M, that's going to be our f prime of a, right? And this is what we're trying to find. But they just write it out in this form. So once I get 1 over 27, this is f prime of a, right? Or f prime of 3 and this, or sorry, f prime of 27. That's what I meant. Here's your f of a is 3. Remember x is the value that we're trying to approximate. Okay, and then just plug it in. Okay with that? So, and honestly, if you're using 27 to approximate the cube root of 26, it's going to be smaller than 3, right? Because the cube root of 27 is 3, so it should be just a little bit smaller. And so you end up subtracting 127 to get 2 and 26, 27. I don't know that I think we kind of ran out of time at that point.
Yeah.
So you could look on your calculator just to see how close that approximation is. And I'm pretty sure it's probably to either the 100th or the 1000th place. Okay. All right, differentials. So differentials lead into kind of the second part of calculus. It's just kind of like a little introduction. The second part of calculus that we do are integrals. So derivatives, think of derivatives as like working forward, and then integrals or antiderivatives are when we work backwards. And some of you are learning that in physics. So
what is it when you're given the derivative of a function, we define the function?
right. So if you start with the derivative, you work backwards to find the original function. Okay? All right, so let's look at, now we're just going to do differentials, and this is why I said it's kind of a portion of integrals, but we're still just doing the derivative. Think of, so if you have a function y equals f of x, right, then dy dx is f prime of x. I mean, it's just notation, right? So imagine if you were to multiply both sides by a dx,
Find dy.
then you can find dy. So if I take this and multiply by dx, it's like these cancel, so I'm left with that result. So dy is equal to f prime of x dx. This is probably the easiest thing that we'll do in this chapter,
Yeah.
because it is a calculator problem. Well, some of you will probably be able to multiply that by hand. Natalie, you have a question?
Just like, what exactly is, if we weren't given, would we ever not be given dx?
Okay, so dy dx is the change in y with respect to x. So the change, it's like, remember d is like
Yeah.
delta. It's the change in y, change in x.
Oh, that's what the d means, right?
It's like a delta.
Oh.
So dx is delta x?
Yes.
Change in x? Okay.
So basically here, your delta x is going to be very small. So we want to find dy, we wanna find the change in y when the change in x is 0.01. Okay, so we wanna find dy, so dy is going to be 5x to the fourth plus 37, and then we just put the dx at the end. That's all you have to do, and then just plug in all your values. So when x is 1, so plug in 1. So we get 5 plus 37, and dx is 0.01.
Wait, shouldn't we have taken the derivative of 5x to the fourth plus 37 because it's f prime of x times dx?
You're not doing the second derivative.
Prime x to the fourth is the derivative of the original function. The original function is x to the fifth.
This is y. So dy is the derivative of this times dx.
Never mind.
Everybody else okay with that? All right. Well, what do we get?
Point four.
There you go. So basically, our change in y, when the change in x is 0.01, is 0.42. Okay? With this particular function. So obviously, it's going to be different depending on the value that you are plugging in. It's going to depend on this. It depends. So all of these kind of depend on each other. So let's look at B. So we want to find the differential. So that's going to be chain rule, right? Cosine 3x times 3 times dx at the end. Don't forget the dx at the end because that's where this comes in. So dy is going to be 3 times cosine of 3 pi times negative 0.02. Cosine of 3 pi is the same as cosine pi, so that'll give us negative 1. So negative 3 times negative 0.02, what do we get?
Positive 0.06.
No? Yes?
I think so.
You think so? I think you're right. Okay, last one. Yeah.
This isn't too bad.
That's why I said this is like the easiest
I
thing from the
love
whole
this.
chapter. So, except for we get a implicit differentiation.
Yeah.
So it's okay, we can do it. Hasn't been that long since we did implicit differentiation. Has it? Okay. We'll take it step by step.
Please.
So, in that case, let me just write, since we have y on both sides, now there's actually two ways that we could solve this, but I think it's okay to use implicit differentiation just to review it.
What's the other one?
Well, this one you can actually isolate the y. This one, y is easily isolated, but then you still have to do quotient rule or product chain rule.
Just do.
I think this is fine. Implicit differentiation is fine. So we get 1 plus dy dx, right? The derivative of x is just 1, but remember derivative of y is dy dx. Now here we have to do the product rule. So it's going to be x dy dx plus 1 times y. Now remember, we're trying to find the differential. So we're going to isolate the dy dx, and then we're going to move the dx to the other side. Does that make sense? Yeah, so this is just algebra. We just want to get the dy. So dy dx minus x dy dx, and then we have y minus 1.
So it's y minus 1 over 1 minus x.
So 1 minus x is equal to y. Well,
Where
actually,
you
we could
lost
just...
your wait, 1 minus x, wouldn't that be equal to...
y minus 1, sorry. That is supposed to be y minus 1. So dy is equal to what? Y minus 1 over 1 minus x dx. You could do that all in one step, or you could divide both sides by 1 minus x.
You can't do this though, can you? That since we have dy as the top and dx as the bottom, and we have a fraction, you can't do that, can you?
Why not?
So, no, but what I'm saying is, saying just dy is y minus 1, you can't do that, right? That doesn't
Were you just-
dy is not just
Right,
1 minus.
Never mind, I'm
Okay.
totally.
I can do this.
I'm getting.
It's okay. Anybody else confused? Okay? It's okay. I thought I did something wrong. Okay, now what? Oh, so now we have an issue because we don't know what y is. Can we figure out what y is pretty easily?
Yes.
Yeah, so just plug it in 2. So 2 plus y equals, right? So plug in x equals 2 to find y. So 2 plus y equals 2y. So y equals 2. Okay, so dy is equal to 2 minus 1 over 1 minus 2 times 0.05.
How did you know?
What's that?
Simple algebra problem that I'm not seeing. But how did you
2
know
plus
that
y equals 2y?
Yeah.
Subtract y from both sides. You get
Oh, okay.
I know, it's like when you get one of those problems that you solved in Algebra 1, like 12 years ago. Say, wait. Okay. What do we get when we're all done? Yeah, because you get negative 1 times 0.05, so negative 0.05. Oops. Okay. So we're going to just focus on homework from now on.
From now on, like ever.
Just today. I'm not going to move, not forever.
I was like, wow.
No more learning.
Wouldn't that be great? We're just going to do homework from now on. We're not going to learn
That'd
any
be
new
so nice.
material.
Well, you could always do like screencasts and like that's what I thought you meant. I thought we were gonna do just screencasts and homework from now on. Like, here we go.
I don't know.
Good question.
And
Have you ever
everything
left
else
this
is
thing
on.
all night on and it just rained? That's what I think.
I usually put it in sleep mode.
Yeah, I forgot. I think I was charging. I charged